here, up here, we're going to get rid of explain 3. So we are not going to do explain 3. Some point, something has to go. So I don't want to just cut everything from the end of the year. So we're going to cut this one out and not worry about explain 3. However, you still need to do the elaborate questions. Okay, so that's still expected to get done because you don't need explain 3 to answer those 3 questions. All right, so you're still doing that part. We are going to work on topic 3.2. Okay, solving absolute value equations today. All right, so that's where we are at. Hopefully you wrote down the essential question and the I can statement. So the essential question is, how can you solve an absolute value equation? And the I can statement is, I can solve an absolute value equation. Okay. So, sorry, I got distracted by the email. All right, so we're going to go through this little explore activity. This does come up in the assignment, so you want to make sure that we are getting this. So, an absolute value equations differ from linear equations in that they may have 2 solutions. This is indicated with a disjunction, which is a mathematical statement created by connecting 2 other statements with the word or. To see why there can be 2 solutions, you can solve the absolute value equation using graphs. So what we're going to do is we're going to graph this absolute value function, and then we're going to graph this side here. Okay, so I'm going to ask for a little bit of help here in a minute, so be ready to help me out in the chat, okay, because it's coming. All right. Okay, so we are going to start with the vertex. So our vertex, remember, we change this sign, so it's going to appear as a +5, and then we're going to keep the sign on the outside -4. So that's my vertex. So, and this graph, the book does crazy things when they scale graphs. So the graph is scaled kind of crazy. It's every 2. So it looks like I'm about halfway in between here, 5, and then I got to go down -4. And then I'm going to use the shortcut method and not the T-chart method. I'm just going to count this slope. So I know I've got to go up 2 over 1, up 2 over 1 in the other direction. But because I'm having to do this for a solving, I'm going to do that a few more times. So up 2 over 1. I know it looks like I'm only going up 1, but the graph is scaled in 2s. Up 2 over 1, up 2 over 1. I'm going to go maybe one more, up 2 over 1. Up 2 over 1. Okay? So I'm going to graph this. Okay. And now we're going to graph this right here. So I want you to think about that. It's an equation of a line. I want you to think about, what is that line going to look like? Okay? Can you tell me what that line looks like? Put it in the chat. No one even has any guesses. A line does not look like a V. It's going to look like a line. Okay, so what we are essentially graphing on this side is y equals 2. Just like on this side, we're graphing y equals whatever this mess is right here. Okay? So when I have a y equals line, and that's all that's there, does anybody remember what that looks like? You remember what it looks like, put it in the chat. Give it another few seconds and see if anybody else has an answer. Okay, Amy's correct. It is a horizontal line. Okay, so let's do a little mini lesson off to the side. Okay, so if you have y equals something with a slope and an x, that's a picture of a line that looks like that, right? If you just have y equals a number, that's a horizontal line. Okay, and if you have x equals a number, that is a vertical line, and you should know that. Okay, so I'm going to graph a horizontal line at y equals 2. So my 2 is up here, and if I didn't remember that, I could just plot everywhere where y is equal to 2, and eventually I'd have enough plots that I could connect the dots. All right, so write the solution to the equation as a disjunction. So my solution to this is everywhere where they cross. Notice it crosses in 2 different places. I'm only going to write the x value, not the y value. So the x value here is 1, and the x value here is 8. So my disjunction would be, I'm sorry, it's not 1, is it? It's 2, because my graph was scaled in 2. See, even I fell into the trap. So it's 2 and 8. Okay, so now we've got some reflection questions. Okay. So I want everybody, actually we're going to do this in a Jamboard. Okay. So I'm going to set a Jamboard out there and we're going to answer this question in a Jamboard. Okay. So why might you expect the absolute value equations to have 2 solutions? Why not 3 or 4? So you start thinking about that question as I create the Jamboard. Okay. And what you're going to do is you're going to add a, I'm getting there. You're going to add just a sticky note to the Jamboard, okay, and answer that question. Okay, so here it comes. It's going to take us a little bit to get it. The link is there in the chat. While you're getting there, I'm going to type in the question. You guys just come over here and hit this little sticky note button and put a sticky note in there for me and answer the question. Why 2 solutions? I'm abbreviating the question. Why not 3 or 4? All right, and I should see everybody in there. This is a little bit more anonymous than the chat, so everybody can participate in this. I want to see what you guys are thinking about this. I'm going to give you a couple of minutes to answer that. Oh, we got one. Good. Awesome. We got a couple. Make sure you move it because everybody's sticky note kind of lands in the same spot. So move it so it's kind of somewhere else on the board. It's interesting that only 15 of you have actually found the Jamboard when there's like 23 of you here in the meet. Hopefully you're participating in your education today. All right, I'm going to wait a few more minutes because I still don't have hardly anybody on this Jamboard. think I'm beginning to see why the grades are what they are in this class. It's getting a little bit better. Hoping it was internet issues. Oh, we've got a giant one now. I'm going to give it about another 30 seconds, see if we can get any more to add on there. Okay, so why are there two solutions? Okay, it's really kind of a simple answer. Okay, I'm going to actually pick on this one. 2 points were crossed twice, right? It crossed the graph 2 times. It would only be 2 since the line crosses the value only twice. It's as simple as that. The 2 graphs cross twice. Okay. So the other question is, is there a way for it to be other than 2 solutions? I mean, obviously we can get 2 solutions. I'm going to go back to our picture here. So we would expect 2 solutions because we know that the V is going to cross twice if I draw a horizontal line there. So I would say something maybe like the V shape allows the horizontal line to cross 2 times. Now, can it cross any differently than that? What if I had a horizontal line, okay, and I drew it like this? Tell me in the chat, how many solutions would that one have? So how many times did it cross, basically? So tell me you're paying attention by putting it in the chat. How many times did that cross? All right, good job. 1 time. Thank you for participating. Okay, so we know it could cross once, right? Do you think there's any other way that this could cross? Or any other way I could have a V and a horizontal? What if I did that? Tell me in the chat, how many solutions does that one have? There we go. Okay, now it's picking up. Awesome. Okay, so this is no solutions, right? And then this one would be our example of 2 solutions, okay? There wouldn't be any solutions. Good job. Okay, the other way you could do this also is everything could be upside down, right? I could do it like that, or I could do all of them upside down. All right. Okay, so let's get into the nitty-gritty of actually solving these things. So these are actually going to probably go pretty quick. I think my video is totaled maybe 15 minutes total. I will try not to talk too fast because I know you can't pause me like you can pause the video and rewind it. But this really isn't that hard of a concept. You should have seen something similar to this in Algebra 1. I know you've worked with absolute values a really long time. Okay, so I think you understand them. It's just understanding the algebra. And there's some rules hidden in this explain 1 here. So to solve an absolute value equation algebraically, first isolate the absolute value expression on one side of the equation the same way you would isolate a variable. So that's pretty important. Isolate the absolute value expression on one side of the equation. I would probably highlight or annotate that some way. if f of x equals a, where a is a positive number, then x equals a, or x equals negative a. I'm going to undo that a little bit. I'm not going to do it that way, because if we start that way, then what we do tomorrow gets more confusing, okay? So what I'm going to say on that piece there is that you have a positive, I'm making sure I'm writing this the right way. We're going to split it into a positive expression and a negative expression, and I'm saying it weird on purpose so you remember it, okay? So notice the use of the disjunction here in the rule for the values of x. You can or you cannot know the original equation, whether the expression inside the absolute value bars is positive or negative, so you must work through both possibilities to finish isolating x. So I have to split it into the two because I don't know on the inside originally what that was, okay? So I'm going to go ahead and try, we're going to try some of these. We're going to literally plot dots on a graph for our answers, okay? That's all there is to the graphing today. Dots on a number line, we can all handle that. So I'm going to start by isolating the absolute value. I'm going to do that by subtracting the 2 from both sides. So 8 minus 2 is 6. Now, in order to take the absolute values off, I have to split it into a positive expression and a negative expression. And notice I put the negative on and the positive on the left side, not the right side like they told us in the instructions. Okay, again, that's setting us up for success when we do inequalities. All right, I'm going to solve these. I'm going to divide by 3. So 6 divided by 3 is 2. I really don't need the parentheses there. So I'm going to divide by -3, and 6 divided by -3 is -2. And really, we should be putting the word or in between there to create that disjunction they were talking about. And then I'm going to plot the -2 and the 2 on the graph. Big deal, right? All right, let's try a few more. Make sure we've got these, okay? So I have to isolate the absolute values. So I'm going to start by adding the 2 to both sides. So that would be 19 plus 2, which would be 21. Then I'm going, and I don't know what it is. I usually have to draw this because people don't get this one. I'm going to divide by 3. So 21 divided by 3 is 7. And then we are going to split it into a positive expression and a negative expression. So a positive expression equals 7, and a negative with parentheses expression equals 7. All right, we're going to add the 5, which would give us 12, and x equals 3. I'm going to distribute the negative, so -4x plus 5 equals 7. And -4x, I'm going to subtract the 5, which is going to give me 2. And then I'm going to divide by the -4, so I get 2 divided by -4, or -1/2, and put the word or in between there for the disjunction. Okay, let's do a couple more. Let's make sure we've got this, okay? Because it should be easy peasy lemon squeezy. All right, so I need to isolate the absolute value. So to do that, I'm going to do the opposite of 1/2, which is going to be multiply both sides by 2. So I get the absolute value of x plus 2 equals 20. I now need to split it into a positive expression and a negative with parentheses expression. So we're going to subtract the 2. So 20 minus 2 would be 18. I'm going to distribute the negative. We get -x equals I'm going to add the 2 over, so it'd be 22, and x equals negative 22. Again, with the word or in between them. I'm being a little sloppy about it by not bringing them down to the same line. And I'm going to plot my dots. So 18 is probably like right in here, because that's probably 20 right here. And then negative 22 is probably just before 24 right there. And I think they're having us practice plotting on there because the next couple lessons we're going to be using the number line to graph our solutions. So they're having us practice that part now. Okay, we got one more of this kind, then we're gonna do something a little bit different. Okay, so I'm going to isolate the absolute value by subtracting 5. So 1 minus 5 is negative 4. I'm now going to divide by the negative 2. So I get the absolute value of 3x minus 6 equals, it's going to be positive 2. Now I'm going to split this into a positive expression and a negative expression. So we get 3x equals 8. And divide by 3, so x equals 8/3. I'm going to distribute in the negative. So negative 3x plus 6 equals 2. I'm going to subtract the 6. So 2 minus 6 is negative 4. And then x equals negative 4 divided by negative 3, or positive 4/3. Now, your graph is split into craziness again. They scaled it in 2/3 increments. So this would be 2/3, 4/3, 6/3, 8/3. I think that's enough that way, right? So we need a dot at 4/3 and a dot at 8/3. It's the craziest labeling of a graph I think I've ever seen. Okay, these 4 examples were ones that we had 2 solutions on. Okay, but we know, because we explored it a little bit, that there's times when we don't have 2 solutions. So we're going to practice a few right now that don't have 2 solutions. Okay, so we're going to do a couple together, and then I'm going to probably have you, we have enough time, it looks like, left to have you try a couple on your own. Okay, so you've seen that absolute value equations have 2 solutions when the isolated absolute value expression is equal to a positive number. When an absolute value is equal to 0, so this would be something to maybe highlight. So when it's equal to 0, there is a single solution because 0 is its own opposite. This one's more important. When an absolute value expression is equal to a negative number, there is no solution because absolute value can never equal a negative. So if I have an absolute value of something, okay, I have a smiley face, and I have it equal to a negative number out here, I cannot do that. There is not a possibility for that to happen. So if it's absolute value equal to a negative, you write no solution. Okay. All right, so let's try a couple. So I am going to start by isolating my absolute value. Okay, sorry. So I'm going to subtract the 2. So 12 minus 2 is 10. Then I'm going to divide by negative 5. So absolute value of x plus 1 equals negative 2. All right. I'm absolute value, I'm equal to a negative. So that means I have no solution. All right, let's look at the next one. So I am going to isolate the absolute value by adding 3 to the other side, which means I've got 3/5. Absolute value of 2x minus 4 equals 0. I'm not going to stop there, okay? Just because it equals 0 doesn't mean I stop. I'm going to get rid of the 3/5 to the other side by multiplying by the reciprocal. So we end up with the absolute value of, sorry, that's a little small, 2x minus 4 equals 0 times 5/3, still 0. We are now going to split it into, and I wrote way too big, a positive expression and a negative expression. And we're going to solve. So 2x equals 4 and x equals 2. I'm going to distribute this in. So negative 2x plus 4 equals 0. Negative 2x equals negative 4. And x equals, I'm going to divide by negative 2. I would get positive 2. So notice, look, it's the same number. It's okay to have that repeated answer, though. Okay, and you can just leave it as the repeated answer. All right, so here's what we're going to do. Actually, I'm going to be quiet for about 45 seconds, let you finish writing. Then I'll tell you what we're going to do. Okay, so I want you to take a chance to try a few on your own, okay? So I want you to look at 5 and I want you to look at 6. I'm going to put on a timer for 4 minutes, okay? In 4 minutes, we're going to look at the solutions to these. So you're trying 5 and you're trying 6 for the next 4 minutes. Okay, don't put anything in the chat until I tell you to, okay? Because there are going to be very specific instructions about the chat. All right, we are almost at time. You guys ready? So let me see how I'm going to do this time. So you're going to answer one thing for me. Okay. There we go. So I'm going to give you an assignment and you're going to put that in the chat. So everybody participates. We're going to check our answers that way. Okay. So if your first name starts with the letter A through, let's say, E. So A through E, type in the chat what you got for number 5. So first name A to E is number 5. Everybody else, E to Z, sorry, not E to Z, G to Z, you guys type the answer for number 6 in the chat. Okay? All right, I got a lot of number 5 answers in there. Still looking for number 6 answers. Oh, I got a number 6. And another number 6. There aren't any F's in the class, Elizabeth. That's why I did it that way. But yes, if your F is not, if your name starts with F, you don't have to answer, apparently. But you have to see this. Like, let me just show you why. This is the sidetrack of the class period. Look at the names. All the A's. There's a ton of A's. This isn't even close to some of my classes, how many A's there are, but like half the class is like A's through E's, and then the other half is everybody else. So there aren't very many. It's very diverse in the last half of the alphabet. The first half of the alphabet is A's and E's. Okay, so that's why I did it that way. All right, let's check it out. So I'm going to go through it. It looks like we mostly got it there, but I want to make sure that we're official and that we've seen it, but I'm going to go fast, okay, because I know we've got to see a joke, right? His joke's okay today. It's not the best, but it's okay. All right, so I'm going to start by subtracting the 7 over, which would give me 2, right? I'm on the wrong screen. Give me -2, actually. I'm going to divide by the 3. So I get -2/3. It doesn't matter that that's a fraction. We don't care because it's an absolute value equal to a negative, so no solution. Okay. All right, on this one here, we're going to subtract the 7. So you got 9 absolute value of 4/3 x minus 2 equals 0. Divide by 9. So you got absolute value of 4/3 x minus 2 equals 0 still. Positive expression and a negative expression, even though we know there's only going to be one answer, right? Because of the rules. I'd still do that because it's a habit and it's a good habit to be in, and it doesn't matter that you've got the same answer twice. Okay. I'm going to add the 2. So I get 2. And then I'm going to multiply by the reciprocal. 3/4. 2 goes into 3 or 4 twice, so x equals 3/2. And just to be official, -4/3 x plus 2 equals 0. -4/3 x equals -2. Multiply by -3/4. So x equals, and double negative is going to be +3/2. So we got the same on both. At least it checked itself, right? Okay, let's take a look at the joke of the day, because I know you only get the joke of the day, like, 2 or 3 times a week. I tried to show you the back jokes, but he didn't do one yesterday. I'm gonna hit stop recording.